8.5 is using intercept form in order to graph these quadratic functions or these parabolas. The first part that we're going to be looking at is graphing in the form of f of x is equal to a times x plus p, or sorry, x minus p times x minus q. Now, I'm not going to require you to graph these. The only thing that we are doing is to find the x-intercepts and to find the axis of symmetry. You can also find the vertex with these by plugging in your axis of symmetry and simplifying. So that could be another option that I will be asking you for with them. So with these, you're going to use a different formula. You're used to seeing your axis of symmetry by using x is equal to negative b over 2 times a. With these, when they are in factored form and you are given your x-intercepts, or you find your x-intercepts, you can use the y values of those x-intercepts in order to get your p and your q, add them together, and then divide by 2. So if we look at the first example, we have f of x is equal to the opposite of x plus 1 times x minus 5. So what I like to do is I like to find my x-intercepts first. So I'm going to set each part equal to 0. So that's going to be the negative 1 is equal to 0, the x plus 1 is equal to 0, and the x minus 5 is equal to 0. And then I solve for each of them. The negative 1 is equal to 0, cancel it out, cross it out, don't work with it. The x plus 1 is equal to 0, move the 1 over by subtracting it from each side, you get x is equal to negative 1. The x minus 5 is equal to 0, add the 5 to each side, you get that x is equal to 5. One of these is p, the other is q. You have x-intercepts of negative 1, 0, and 5, 0. So with these, the negative 1 can be your p, the 5 can be your q. It's totally up to you which one you use, doesn't matter. You're going to get the same thing because you're just adding them. So if we do negative 1 plus 5 divided by 2, it gives us the axis of symmetry of 4 over 2, which is x is equal to 4. Or sorry, x is equal to 2. That is your axis of symmetry. From here, if it asks you to find your vertex, plug in the 2 and simplify. It'll give you your y value, and then you'll have an x and a y, that's your vertex. So if we do that, we would have y is equal to the opposite of 2 plus 1 times 2 minus 5. 2 plus 1 is 3. 2 minus 5 is negative 3. The opposite of 3 is negative 3 times negative 3 gives us a y value of 9. So our vertex then is the ordered pair 2, 9. And then we said that this x is equal to 2 is your axis of symmetry. For example, B, we have f of x is equal to x plus 2 times x minus 3. So again, I'm going to take each of these and just set them equal to 0. So x plus 2 is equal to 0, and x minus 3 is equal to 0. First, find your x-intercepts. So you're just solving for x. You're going to subtract the 2 from each side. You get that x is equal to negative 2. Add the 3 to each side. You get that x is equal to 3. So your x-intercepts are the ordered pairs negative 2, 0, and 3, 0. Now, to find your axis of symmetry, do your negative 2 plus 3 and divide it by 2. The negative 2 plus 3 gives us 1 over 2. So your axis of symmetry is x is equal to 1/2. So you have your x-intercept so far. You have your axis of symmetry. Next thing that you can do is to find your vertex. You have what x is equal to, plug it in, and solve for y. So for your vertex, we're going to have y is equal to 1/2 plus 2 times 1/2 minus 3. Remember, when you're adding and subtracting fractions, you need like denominators. So both numbers have to be over 2. So this is going to be 1/2 plus 4 over 2 times 1/2 minus 6 over 2. The 1/2 plus 4 over 2 gives us 5 over 2. And the 1/2 minus 6 over 2 gives us negative 5 over 2. From here, we have a y that is negative 25 over 2. So our x was 1/2, our y is negative 25 over 2. Our vertex is the ordered pair 1/2, negative 25 over 2. For example C, we have g of x is equal to negative 2 times x minus 4 times x plus 1. So again, we're going to set each part equal to 0 and solve for x. So that way we have our x-intercepts. For that, negative 2 is equal to 0. It's a false statement. Cross it out. Don't work with it. Forget about it. The x minus 4 is equal to 0. Add the 4 to each side, and you get that x is 4. For the x plus 1 is equal to 0, subtract the 1 from each side. You get that x is equal to negative 1. So to find your axis of, if you want, write down your x-intercepts. You have 4, 0. And negative 1, 0. From here, find your axis of symmetry. Your axis of symmetry is going to be that x is equal to the two x values from your x-intercepts, so 4 plus negative 1 divided by 2. The 4 plus negative 1 gives us 3 over 2. So our axis of symmetry is x is equal to 3 over 2. Now I'm going to keep this as an improper fraction, so that way it's easier for me to add, subtract, that kind of thing. From here, I'm going to find my y value, so that way I have my vertex. My y can be found by doing y is equal to negative 2 times 3 over 2 minus 4 times 3 over 2 plus 1. The 3 over 2 minus 4, I'm going to change the 4 to be 3 over 2 minus 8 over 2. And the 3 over 2 plus 1, I'm going to change the 1 to be 3 over 2 plus 2 over 2. From here, we're going to have y is equal to negative 2 times negative 5 over 2 times positive 5 over 2. When we multiply, we're going to have y is equal. This cancels this one out. These both turn positive, so that's just 5 times 5 over 2, which gives us y is equal to 25 over 2. So your vertex is the ordered pair 3 over 2, 25 over 2. For our next part, we're going to be solving our x, or giving our zeros with these. So what I want you to do is to think about factoring. With example 2a, we have f of x is equal to 2x squared minus 8. You have to factor out your greatest common factor here. So this, we're going to factor by factoring out a 2. So it's going to be 2 times x squared minus 4. That x squared minus 4 is a difference of squares, because you can take the square root of both of these and you have a negative in between them. So that's going to give us f of x is equal to 2 times x minus 2 times x plus 2. Now you are at the same exact part that you were in the examples before this. So set each part equal to 0. And solve for the variable. The 2 is equal to x. Doesn't matter. Cross it out. You're going to get that x is equal to 2 and x is equal to negative 2 when you move those 2's over and get x by themselves. This gives you x-intercepts of negative 2, 0 and positive 2, 0. To find your axis of symmetry, use x is equal to negative 2 plus 2 over 2. The negative 2 plus 2 is 0 over 2. 0 over anything is 0. So your axis of symmetry is x is equal to 0. From here, to find your vertex, plug it in and simplify. You can do either the top, the one that was given to you, or the one you factored. You're going to get the same exact answer. If we do the one that's on the first one that they gave us, we're going to have y is equal to 2 times 0 squared minus 8, which is just going to give us y is equal to 2 times 0 minus 8, which is y is equal to 0 minus 8, and that's y is equal to negative 8. So our vertex is the ordered pair 0, negative 8. For example B, we're given h of x is equal to 4x squared minus 36. So again, we're going to start this one by factoring out the greatest common factor, which is 4. So this leaves us with h of x is equal to 4 times x squared minus 9. That is a difference of squares in those parentheses, so it factors out further to be h of x is equal to 4 times x minus 3 times x plus 3. To find our zeros, our x-intercepts, we're going to take each part, set it equal to 0, and then solve. That 4 is equal to 0, cancel it out, cross it out, don't work with it. The x minus 3 is equal to 0, add the 3 to both sides, you get that x is equal to 3. The x plus 3 is equal to 0, subtract the 3 from each side, you get that x is equal to negative 3. So your x-intercepts here, or your zeros are the x is equal to 3 and the x is equal to negative 3. If they ask for your x-intercepts, you're just going to give 3, 0, and negative 3, 0. From here, find your axis of symmetry. You have 3, you have negative 3. So x is going to equal 3 plus negative 3 all over 2. 3 plus negative 3 is 0 over 2, which gives us 0. So our axis of symmetry is x is equal to 0. From here, find your vertex. You have y is equal to 4 times 0 squared minus 36. So this is going to give us y is equal to 0 times 4 minus 36. So it's y is equal to 0 minus 36. So y is negative 36. So our vertex is the ordered pair 0, negative 36. For the next part in your notes, it's just asking you to find the zeros of each function. When you find the zeros, you're just solving for x. So it means the same exact thing as solve for x. If it's factored for you, half of your job is already done. Set each part equal to 0, solve for the x. For example, 3a, we have f of x is equal to x minus 1 times x plus 2. So we take that x minus 1, we set it equal to 0. We take that x plus 2, we set it equal to 0. For x minus 1 is equal to 0, add the 1 to both sides, and we get that x is 1. For the x plus 2 is equal to 0, subtract the 2 from each side, and we get that x is equal to negative 2. So your zeros here are x is equal to 1 and x is equal to negative 2. For example, B, we're given f of x is equal to x minus 6 times x minus 1. So again, we're going to take each part. We're going to have that x minus 6. We set it equal to 0. We have that x minus 1. We set it equal to 0. Add the 6 to each side. You get that x is 6. Add the 1 to both sides. We get x is equal to 1. So x is equal to 6, x is equal to 1. Those are your zeros. Sometimes when you're told to find the zeros of a function, your function will not be completely factored. So you're going to have to factor it for yourself. If we look at example 4a, we have f of x is equal to negative 2x squared minus 10x minus 12. Think about when we factored. Ask yourself first, do you have a greatest common factor that you can factor out? If you do, factor that out first. From there, is your a 1? Do you have a difference of squares? Do you have the sum of, the perfect square trinomial? Can you find the factors of your c term that add up to be your b term? Is a not 1? You got to take into consideration all of that. If we look at this example, we can factor out a negative 2 from each of those terms. So we'll start by doing that. So this is going to give us negative 2 times x squared plus 5x plus 6. I'm going to set this equal to 0 so that way I already prompt myself into solving for x. From here, my factors of 6 that add up to be 5, since a is 1, are 2 and 3. So this factors out further to be negative 2 times x plus 2 times x plus 3 is equal to 0. From here, I'm going to set each part equal to 0 and solve for the variable. So I'm going to have negative 2 is equal to 0, x plus 2 is equal to 0, and x plus 3 is equal to 0. That negative 2 is equal to 0, forget about it. It's not a true statement, so get rid of it. The x plus 2 is equal to 0, subtract the 2 from each side. You have that x is equal to negative 2. For the x plus 3 is equal to 0, subtract the 3 from each side. You have x is equal to negative 3. So your two zeros here you have are x is equal to negative 2 and x is equal to negative 3. For example B, we have h of x is equal to x minus 1 times x squared minus 16. That x squared minus 16 is not completely factored, so we're going to factor it further and set it equal to 0. So we're going to have x minus 1. It's a difference of squares, so it's going to be x minus 4 times x plus 4. And again, we're just going to set it equal to 0. Now that it's completely factored, we set each part equal to 0. So it's going to be x minus 1 is equal to 0, x minus 4 is equal to 0, and x plus 4 is equal to 0. The x minus 1 is equal to 0. Add the 1 to each side. You get x is equal to 1. The x minus 4 is equal to 0. Add the 4 to each side. You get x is equal to 4. And then x plus 4 is equal to 0. Subtract the 4 from each side. You get x is equal to negative 4. For example C, we have g of x is equal to 3x squared minus 12x plus 12. So for this one, we're going to factor out a 3 from each of these terms to start. So it's going to give us 3 times x squared minus 4x plus 4 is equal to 0. From here, your factors of positive 4 that add up to be negative 4 are negative 2 and negative 2. So this factors out even further to be 3 times x minus 2 times x minus 2 is equal to 0. From here, you're going to set each part equal to 0. So that 3 you can get rid of because it doesn't have a variable attached to it. You then have x minus 2 is equal to 0, and x minus 2 is equal to 0. Now, these are both the same exact thing. So if you want to just solve one, not the other, you can. If you want to solve both, you can. So you would just add the 2 to both sides, and you get that x is equal to 2. Again, if you did that to the other, you get the same exact thing. Do you need to give me both twice? No. So you can just highlight the 1, and then that's your answer. For example D, we have h of x is equal to x times x squared minus 1. We do have to completely factor this. That x squared minus 1 is a difference of squares, so this becomes x times x minus 1 times x plus 1 is equal to 0. Set each part equal to 0. That x that's by itself, it has an x attached to it, it's a variable, set it equal to 0. That x minus 1 set equal to 0, and that x plus 1 set equal to 0. We're going to move the negative 1 over, we're going to move the positive 1 over. So we get that x is equal to 0, x is equal to 1, and x is equal to negative 1. So our zeros for this one, we have 3. 0, negative 1, and 1. For your next set of examples, we are just finding the zeros again. Okay, so for A, they give us h of x is equal to x squared minus 2x minus 3. So we want the factors of that negative 3 that add up to be negative 2. So it's going to be a 1 and a minus 3 that give us negative 2. So this factors out to be x plus 1 times x minus 3 is equal to 0. Set each part equal to 0 and solve for your variable. You get that x is equal to negative 1. You get that x is equal to 3. So your zeros are that x is equal to negative 1 and x is equal to 3. For example B, we have f of x is equal to x minus 1 times x minus 4. So again, this is factored for us. So set each part equal to 0 and just solve. So we get that x is equal to positive 1 and x is equal to positive 4. And for our last example of this lesson, we have g of x is equal to x squared plus x minus 12. Your factors of negative 12 that add up to be a positive 1 are negative 3 and positive 4. So this we're going to factor to be x minus 3 times x plus 4 is equal to 0. From here, you set each part equal to 0. And you get that x is equal to 3 and x is equal to negative 4. Oops.